Hello, everyone, and welcome to another NETGEAR webinar. Happy Pi Day. So today is our last webinar for the quarter, and I am your host, Sarah Moreno. And today, we're going to be learning how to enable Wave 2 802.11 AC, developing M4200 aggregation switches with the WAC740 Wave 2 access points. And here to talk about that today is our NETGEAR product line manager, Laurent. He is live with us from France. And if you have any questions during the presentation, please feel free to ask them in the chat room. And one last thing, we'll be giving away another NETGEAR backpack cooler. We're raffling that off today. And just to be able to win that, you just have to join this webinar. So you guys are all entered if you're listening. All right, take it away, Laurent.
Thank you very much. Hi, everyone. This is Laurent. That's true. I'm talking from the old Europe, but I hope that the voice quality is good enough today during my travel. Welcome to that webinar. We are very happy. That's actually a first because we will not only show a couple of slides for an introduction, but we'll go through a real product demo, and we will manipulate our switches and see how we want to configure that to make a great Wave 2 wireless AC network, because we today want to go over that new IEEE 802.3bz NBASE-T, which is really a foundation for Wave 2 with a much bigger pipe for that wireless throughput. So without further ado, we'll go over that quick introduction with the NETGEAR switch portfolio. As you may know, well, we have many switches, but today for wireless Wave 2 AC, we will focus on the M4200 because the M4200 is one of its kind. It's a multi-gig Ethernet switch, and by this multi-gig 2.5/5/10 gig, that's a great solution for aggregating wireless AC, especially with Wave 2. So M4200 switch, let's I have a technical difficulty to go over my slide. Don't worry, it's coming. Okay, so M4200 switch is a fully managed switch platform. It comes with 8 ports of full power PoE+, so good old RG45 ports. But the thing is that all these 8 ports of full power PoE+ are multi-gig Ethernet. Means 8 times 2.5 gig. 2.5 gig per second. Obviously, it's compatible with 1 gig or fast Ethernet, but it's very good for this Wave 2 new standard for wireless access points, because 1 gig is not enough for the wireless throughput, so 2.5 gig really was designed for enabling Wave 2. On top of these 8 ports, 2.5 gig, we have 2 10 gig uplinks, which will be good for aggregating all that wireless throughput in a very line rate fashion. Why? Because 8 times 2.5 gig really means 20 gig of bandwidth. Those 20 gigabit per second of bandwidth will be delivered as an uplink in aggregation to the core. So this M4200 switch comes with a very innovative form factor. We call it easy mount. It means that not only we can go to a rack with the rack mount kit, it's a very slim design, but also sometimes or often, really depends on the conditions, we'll want to hold that switch closer to the access point. So this switch will go where other switches just can't go, with a mount plate and with a lot of accessories to go on poles, to go on ceilings, on walls, circular poles, round poles, rectangular poles. So all the accessories are found with that switch so that we can facilitate the access point placement instead. Okay, so now let's have a look. The wireless portfolio at NETGEAR is a very broad portfolio now, and you see a lot of AC. And at the top of the portfolio, for the top of the line, you can see now the WAC740, which is the 4x4 first wave 2 high-end access point at NETGEAR. So what does it mean? It means that it's 802.11ac 4x4 wave 2. It's designed for customers requiring ultra high density and superior performance. It comes with 2 Ethernet ports, and one of them is multi-gig Ethernet. That's what we are going to use in this demonstration today. So let me tell you right now that the WAC740 operates with MIMO, obviously, as a wave 2, and speeds, it can achieve up to 600 megabit per second on the 2.4 gigahertz band, 600 meg, but on the 5 gigahertz band, you can achieve up to 1.7 gigabit per second, 1.7 gigabit per second of wireless throughput on the 5 gig band. So 600 meg, 0.6 plus 1.7, we are at 2.4 gigabit per second of wireless throughput. That's why Wave 2 really requires multi-gig Ethernet in order to work. So, WAC740 is a controller-managed access point, means that this controller requires a fully featured hardware controller, such as WC7500, WC7600, or WC9500. Today, we are going to enable that Wave 2 installation and connect these access points. Will not go through the wireless controller installation, though. Okay, so let me give you a few words before the actual demo. Before Wave 2 11AC, access points such as the NETGEAR WAC720 or 730, respectively 2x2 and 3x3, they were actually delivering less than 1 gigabit per second somehow of wireless throughput. So 1 gig port, 1 gigabit Ethernet port was enough to just aggregate that wireless throughput. PoE also very often was a standard PoE, so understand 802.3 AF with less than 15.4 watts per port. But with Wave 2, well, we just calculated the overall throughput for that 4x4 WAC740 new top-of-the-line AP. 2.1 gigabit per second as a Ethernet port for aggregation is not sufficient at all. So NETGEAR Wireless team made the decision to come with a 2-port design for the WAC740 so that 2 ports can be used with lag, typical channeling for customers without multi-gig Ethernet capability. But today, really, that's the point. We want to demonstrate how good, how great it is when we use only 1 port on the multi-gigabit Ethernet side with the 2.5 gig port on the right-hand side. So what's NBASE-T? Well, at the beginning, NBASE-T was an alliance. So NETGEAR was one of the founding members of that NBASE-T alliance in the industry. And since then, NBASE-T alliance with the NBASE-T standard, pre-standard, became IEEE certified standard. So now it's called IEEE 802.3BZ, and obviously M4200 is fully compatible, as well as the WC740. So as we just saw, well, the first thing about the history of NBASE-T, it's all about wireless. And we knew that Wave 2 was going to deliver far more than 1 gig per second. Now, 10 gig base T was not good enough because it was pretty expensive, and also because 10 gig base T, we know it requires brand new wiring. In most installations, we don't find Cat6a, because Cat6a is the one required for 100 meters run for base 10 gig base T. So because of that wiring situation in terms of installed base in the US, in Europe, and the rest of the world, it was necessary to come with a new speed able to leverage Cat5, Cat5e installations that are everywhere in every building. So NBASE-T was designed to enable 2.5 gig per second, and simultaneously with compatible devices, 5 gig per second, up to 100 meters on very legacy Cat5e, so 20-year-old wiring installations, and Cat6, which 10 gig base T as a standard just can do. So that's backward compatible. And again, well, it looks like 1 gig. It's good old RG45 jacks, but it's 2.5 and 5 gigs simultaneously. Okay, so how do we want to deploy Wave 2 access points today? During that webinar, we want to replicate a very real-world installation. You can see here that, well, Wave 2 today is ubiquitous. So when Wave 2 wireless getting installed, we really want to have unstoppable operation for the wireless. And how do we get unstoppable operation? We need to have a overall redundant installation. So redundancy is the very first important pillar. Second, we want to have a high performance installation, because again, we see that, well, Wave 2 is all about aggregated throughput way above the 1 gig per second up to 2.4 gigabit per second on WAC740. So those two reasons, redundancy and throughput, really lead to the M4200 switch that was designed from the ground to deliver those two parameters for Wave 2. First, we have high performance because each single switch comes with 8 ports of 2.5 gig, but please count with me now, 8 times 2.5 gig half duplex, right? Unidirectional in one direction. We know that everything then is full duplex with bidirectional traffic, but just one way, one directional egress, for instance. 8 times 2.5 means 20 gigabit per second of unidirectional throughput. That's the reason why every 8 switches, we will have 2 10 gig uplinks going in aggregation to the core, so that 8 times 2.5 gig access points will be totally line rate with the core and the rest of the network. So that's how we want to develop, to deploy those access points. We'll get a stack of 2 wire speed 10 gig switches, for instance, like the M4300s. And another possibility could go with a pair of M6100 chassis going virtual channeling, or MLAG or VSS, you can call it the way you want, so that we can group them in the same fashion. So for the sake of the demonstration today, we are going to use M4300 10 gig switches with a stack, so that we have this fully redundant installation and that overall high performance operation. So to let you give that overview, we'll see those 2 M6100 chassis, for instance, deploying the M4200, and the complete picture comes the whole view. Now that Wi-Fi again is very omnipresent, it can turn into the primary access layer, for instance, in many organizations such as schools, and this way we really have unstoppable operation when and only when we have a core installation capable of a fast failover with non-stop forwarding, which is the case when we use MLAG on the powerful M6100 chassis switches, or when we use high-end stacking technology on the powerful 4300 stackable switches. Okay, so we are 14 minutes now into this webinar. That means the exact half time. I think it's time to go through the demo. That's what we want to configure today for the hands-on. We have first a core installation. We want to stack two M4300 10G switches to have a very reliable, high performance, and highly redundant core installation. Second, we will set up a M4200 switch. We will redundantly connect to that core, and then we will be able to, as a connect a couple of WAC740, see how this 2.5 gig per second operate. So you have a chat box. As soon as you have a question, please use the chat box, because everybody is muted on that call, so I won't hear you. Please use the chat box, ask your questions. We will reserve 10 to 15 minutes at the end of that session, so in 15 minutes from now, to go over the questions and obviously answer all your questions. So keep me honest, guys. That's the first time we do that in this manner. So I'm going to stop sharing my screen. It requires a lot of CPU, actually. That's good. Okay. So I stopped sharing my screen, and now you probably see, I hope so, my two 4300 switches right there. They are right now only linked with two different 10 gig links using the SFP Plus ports. So we use DAC direct attach optical cables. So M4300s, these ones are half width. We have a 24 ports on the left-hand side with 12. We have a 16 ports on the left-hand side with 8 fiber and 8 copper 10 gig, so SFP Plus and 10 NBASE-T. And we have a 24 port version on the right-hand side, this time with 12 SFP Plus fiber and 12 copper NBASE-T ports. So let me take you through the configuration for this. I am going to reshare my screen. Let's go share my screen number 2. Here we go. So the first thing to know, well, we need to know which IP address we got on these switches, and that's the reason why we have plenty of different means. So DHCP servers on the network, well, that's one possibility. We can look at the DHCP leases, IP address scanners, or the NETGEAR NMS300 management software. But the good old method is the USB cable on the console cable. That's why it's always good to have a fully managed switch platform, because we can plug that cable and then click enter, and then we can actually see the user invite. Username is admin by default, no password, and we see that we are connecting to that M4300 8x8F first switch. Pushing enter, pushing enable to go into the global admin mode, I can simply enter show IP management with tab. And then we know now that the IP address for the management VLAN on that switch is 192.168.142. So that's good, because now we can get to a web page together, 168.142. Let's log onto the web page. I have my M4300 switch in front of me. Let's immediately go to stay in system, go to stacking together. because the most important thing to do first is to go to stack and configuration and stacking port configuration so that we can enable the stack mode on 2 ports, which are the ports number 2 and the ports number 4 on that first switch. When logging for the first time to such a stackable switch, we want to first enable stacking mode on a couple, 1, 2, or more 10 gig ports in order to enable stacking. So that's what we do here on the first unit. And going to the second unit, we are going to obviously do the same. Symmetric ports are always better, I can tell you as a good hint. And we are going to enable stacking on the first 2 button ports on the left-hand side on the right switch. So after that, we just need to boot the first switch and wait it has booted and connect the second switch, boot it up, and then we form the stack. Let me show you how is it going now that we have a stack up and running. When we go to the device view, still under the level 0, the system, so before layer 2 switching, before layer 3 routing and QoS and security, just staying in system, we see the device view. Actually, switches are vertically placed, so they are not left and right, but still we can see the 2 ports that we are using each time for the stacking. Last couple things I want to tell you about stacking. Going back to stacking, we see those 2 switches now. We have a priority set for the left-hand switch at 15. It means that this switch got the master role, the management role. We want it to be this way so that on the left-hand side, we always have the master, and we have a lower priority that I assigned to 14 so that I make sure if I have other switches on the stack that this one, the right-hand side, will stand by as a backup unit. It's very important to plan for that, not only because we want to keep those USB cables plugged in for serial access for the serial console, but also because we want to benefit from the non-stop forwarding. NSF is very important. It's enabled by default. Non-stop forwarding means that when it's enabled, the 2 switches can fail over and fail back without any service interruption for all distributed link aggregation across the stack. It means that traffic will continue to flow in and out on the other switches when the master role is transitioning from the first switch to the second switch. So NSF is important. That's why you want to know which one are the switch masters. Okay, so let me take this away, stop sharing. Now, I want to deploy and get that 4200 switch placed in. So the 4200 switch is over there. I am taking it. You see it's coming. This switch is already plugged on the USB serial console. This switch is factory default as I speak, and we have the power cable on the front because that's this very innovative easy mount. You see those holes for the mount on the back. We have the same on the bottom. This way we can actually easy mount that switch using the plate, but also we can use the rack mount kit. Very slim design. That switch is now on the top of the 2 others. For that demonstration today, I'm going to use a good old RJ45 jack in order to connect that switch using a copper PoE plus ports to 1 10 gig Ethernet ports on my right-hand side switch. Okay, I am going to now show you, we have the link established. So one of the PoE ports, we use it on the right-hand side core switch just to establish the connection. So let's reshare this screen. This time we want to log to this M4200 switch. That should be this one, the COM number 4. So again, it's good because with that USB cable, okay, let me see. Yeah. Okay, so unfortunately we lost the connection for the, that's a good exercise though. We lost the connection on the USB for any reason. That's okay. What we can do now actually is go back to our M4200, M4300 switch immediately. And we can maybe use under the system tab, the LLDP table, because LLDP is also supposed to tell us which other devices are connected. So going to the remote device inventory, that's actually good. We see that the M4200 switch is connected on the port number 13 on the second unit. Let's go and click on that. And yes, we see that the M4200 switch is right there, ready to go. It did catch the 143 IP address. So I actually don't need my USB. I would need to actually disconnect the USB port and reconnect it to get it back. So 192 and 168, 143. Let's copy and paste this one. Here we go. So this is the same look and feel with those new web interfaces on the latest generation of NETGEAR managed switches. It works very well, very fast. We see this switch on the system tab. We see the IPv4 management address that this switch actually got through DHCP. This is good. Okay, so quick now, let's go to the device view. We actually have that port number 10, so the 8 copper ports on the right-hand side working. This is how we connected that switch to the core. But remember, what we want to do now, we want to have a redundant installation using the two 10 gig ports bonded together going to the core. So the mission today is actually to use the 10 gig SFP plus ports on the right-hand side, which are the port number 1 and 2, and form that lag. So how do we configure a lag using the web interface on the NETGEAR managed switch? Very easy. That's layer 2 operation. So we go to switching, and then we go to lag. This is a simple unit, and in our system always we have those link aggregation group, those ether channel ports, if you like. They are pre-provisioned in the system because we have 8 ports. We have 5 different lags that are provisioned in the system. So let's just take the first one, click on it. We are going to use the lag number 1, pre-provisioned socket. Give it a name. Well, that's the M4300 redundant installation, maybe. That's good. Lag description, we can just say that we are going to use 2 SFP+, which is actually really what we want to do. And remember, the 10 gig ports are on the left-hand side. Usually they are on the right-hand side, I know, but this time on the M4200, for convenience, they are on the left. So I'm going to select the 1 and 2, so the 2 first ports that actually are the 2 SFP+, 10 gig physical interfaces. I am going to click apply. Intentionally, I'm not going to touch the hash mode right now, but maybe something that I want to do, the link trap is good. I am going to enable link trap so that my SNMP management platforms will get those traps when there is a link disconnection, when there is a link connection, or when there is any flapping. So applying this, I am forming the lag instantly. Going back to the lag now, I see that M4300 name, that's still the lag number 1, ID number 1 with my description. And the hash mode by default is source destination MAC address alongside, VLAN and incoming port. I'm going to change that to something more powerful. I want to have hashing across that link aggregation based not only on source and destination IP, but also TCP UDP. So instead of going physical MAC address hashed algorithm, I want to use source and destination IP and source and destination TCP UDP ports. That will give me a very, very powerful lag algorithm. So in order to do that, I need to click on the first row, obviously, select the number 6, clicking apply, and that should be done. So now I have, let's reconfigure that correctly. Apply. Okay, so now this settings was taking into account my M4300 lag, now use source and destination IP and TCP UDP for the algorithm. That's good. So before doing anything, remember when clicking apply, you actually write into the running configuration. But if you want to save the configuration, you need to go by maintenance and go save config so that the running configuration apply will be written into the startup configuration this time so that all your settings will survive for the reboot. Okay, so going back to the device view, I am going to stop sharing my screen again because I want to physically show you that we want to use, for the sake of that demonstration today, 2 different SFP plus typical DAC cables. Let's connect the first SFP plus. I chose, by the way, does anybody remember the ports we chose? I think we didn't choose the right ones. Let me go back real quick. Share screen. Okay. That's the demo effect, but that's very interesting. Yeah, I was good. We chose to connect the first 2, but well, my mistake comes from the 4300. Now that we have our lag established on the 4200, we need to do the same on the host. So we need to do the same on the core. So go back with me on the M4300 stack. We are going to repeat the exact same operation. Switching for the lag, we want to form a lag. Maybe show that to you first. Going to the system, going to the device view, what I propose today for that installation, we are going to pick the last fiber ports on the right-hand side. So the port number 8 on the first switch and the port number 12 on the second switch, okay? So 8 and 12. Going to switching, going to lag. I am also going to use the first lag 1 that is provisioned in the system because the 4300 are a stackable switch family with 8 switch capability. We have a lot of different lags that are provisioned, actually 128 in the system. So no worries, I'm not just going to use the first one. The lag number 1, the lag name is going to be M4200 redundant, for instance. Let's say that it's unit 1, port 8, and unit 2, port 12 as a description. Let's enable the link trap as well. And then we said that on the unit 1, we want the last SFP plus ports, which is the port number 8. And on the unit 2, we want the last SFP plus port, which is the port number 12. We are good. Before clicking apply, let's select the same hashing algorithm. Remember, we chose the number 6, source and destination IP, and TCP UDP layer 4 port information for the algorithm. It's really important when LACP is used, understand when static mode is disabled, because static is static. No static means auto, LACP. We need to have the the very same hashing algorithm selected on both ends of the Ether channel connection. Clicking apply. Let's control that now. We are almost ready to connect our switch. Going back to the lag page, we have our M4200 redundant name for the lag number 1, the port 108 and 2012, which is good. And we have the good 6 source and destination IP and TCP used. That's good. So stop sharing my screen. Going back to my installation, I take my first DAC connection. I'm going to connect to my first left-hand switch, which is the port number 8. So that's the first physical connection for the installation. Now, at this time, I should probably remove the connection for the copper, but really for that demo, I want to tell you that it's not a problem to have loops on NETGEAR fully managed switches, so I will keep that this way. Let's take a second cable. This time, we are going to use the second port, the second fiber port on this M4200 top switch, and we are going to the other switch on the right-hand side, which is the last fiber, the port number 12. This way. Okay. So click the quick verification. We have lights now on both ports on the top, and we have that link for the link aggregation going okay. So we just connected the M4200 on the left-hand side here to the M4300 stacking core in a very redundant fashion. So let's quickly have a look, going back to the M43 web interface, going to the system, going to device view. And on the device view, we see those 2 fiber ports light. So that's okay. I still have this one, but I really want to see what is going on those 3. So before jumping to the port detailed and summary statistics, I'm very curious, going back to my switching lag port, I want to see quickly if my lag is up and running. That should be the case, but that's a safety check. The M4200 redundant lag now show that the active ports are 108 and 2012. The lag state is up, so I'm good. You can also go to the port table. For instance, on the 8 SFP plus port, we see DAC, its trunk number, it's up, and if I display the lags, I should see that as well. So that's good, because we have now this lag on the M4300 side up. Going to the M4200, I want to see the exact same thing under the device view. And surprisingly, I have my lag over here, which is working well. Let's check, switching, lag. I want to verify that lag is up and running. Yes, active ports are up and running. And on the system device view, I actually can attest that I do have a loop, because this lag is up and running and this port is still green. So let's have a look. My suspicion is, because I did not lose access, that one of these 2 is actually down by spanning tree. So in order to verify that, we just need to go to the spanning tree port configuration and the spanning tree port configuration status. We are pretty sure that's right. The port number 10 that we initially used for the copper connection initially is discarding traffic. And that's good, because our network is up and running. Spanning tree actually took care of it. So on the small window, you are going to see me disconnecting that port on the 8 copper side, so that we don't have it anymore, creating that loops. Instantly now, going into update, I should have that message gone. So the port forwarding state is not discarding packets anymore. So I'm all set on my M4200 switch. It means that as a last check, I can now go to the port detailed statistics, for instance. Let's go to the summary statistics. So the interface number 1 and the interface number 2 receives packets without errors, and we can see the logical entity, which is the lag, the same. Okay, so it's time now to install and really enable WAV2. Remember, we set up the M4300. We now have M4200 connected with LACP. We want now to connect a WAV2 access point. So that's very simple. Let's stop sharing. We are going to take one access point, WAC740. As you can see, well, these access points come with a slot for the power adapter. We are certainly not going to use it. There is a console port, a good old RG45 serial port, and then 2 Ethernet ports. One of them is a 1 gig. The other one is the first one, 2.5 multi-gig NBASE-T port. That's what we want to use. So we are going to connect that 2.5 gig ports onto a 2.5 gig port on the 4200 switch, for instance, over here on the port number 7. And that's the beauty of PoE. There's not much to configure because by default, there is LLDP negotiation. This access point requires around 20 watts of power at the first handshake. So this access point is now booting, and we see all green lights, which mean we are good to go. Let's have a look now on the M4200 web interface. So, going back to the M4200 switch, that's interesting. Yes, perfect. So after the refresh, you see that the port number 7 is green and flashing. It means that we have a connection. I want to immediately go, because I'm very curious, to the port detailed statistics, but let's go to the port configuration first. So the port number 7, which is the one we are using, is actually enabled, and we have a 2.5 gig. We have a 2.5 gig connection as a physical status. So we have a successful 2.5 gig connection on this access point. Now I want to have a look on this AP. I want to see if I do see packets going through. So for this, I can actually use some telnet. Well, times is running against me, so I actually observe that I should have got a sequential IP address after the 2, after the 3. That should be the number 44, and that's here we are. We see, that's right, admin and passwords should be the default credentials for WAC740. So we do have communication with WAC740. This is a controller managed access point, so there's not much we can do on the GUI, but we can actually manipulate Ethernet settings for IP, and it's by default DHCP, and that's good because my DHCP server attributed the next sequential one, so the 44. Okay, we are good to go now. I want to go back to my device view. The statistics look good, and now we want to observe how is the redundancy. So remember, in this setup, we not only want to have redundant, we not only want to have line rate installation, which is the case, 2.5 gig over here, 10 gig uplinks, 8 times 2.5, it's 20, that's what we have, but we really want to have unstoppable operation. And the redundancy comes from the core in that typical setup. So let's run a quick instance with my very simple command line on my screen. We are going to ping together the IP for that access point, which is 192.168.144. That should give us continuous ICMP, And the last operation I want to do with you, let's disconnect one of these two 10 gig switches at the core, simulating maybe somebody pulling the plug or a hardware unlikely event, but hardware failure at the core. So what do you want to do? We can actually disconnect the left-hand switch or the right-hand switch. Because the left-hand switch is our master switch, we want to disconnect the first switch because that's the most difficult one, right? The M4300 master switch. So to do that, I am going for the last time to stop the share, and let's go and actually pull the plug on the left-hand switch. The power supply is on the right, the back. I am just removing the power from my left-hand switch. So my master switch just died, okay? What is expected is that because that second switch was the redundant master switch, the redundant management unit, that switch instantly took over. So there's absolutely no service interruption in theory for all devices going through both switches in a redundant manner, such as my 4200 switch installation today, because I'm not only connecting the left switch, but the second switch. I'm going to let the power code right there. Let's control how it goes now in terms of LACP traffic, resharing my screen. And that's pretty good because you can see that I do not see any packet loss. My left-hand switch in that setup, this one is gone. So now I only have my right-hand switch, but because of our high-end non-stop forwarding capability on the 4300 core stack, we do not see any service interruption in case of a master switch failure. I just want to remind you that when NSF is not a requirement at the core, well, you have a general service interruption for the entire stack. So that's pretty much it today. I hope you enjoyed this M42/WAC740 configuration. As a summary, we set up a core of 10 gig M4300 switches, formed a lag. We went through a lag configuration on the 4200 switches and connected WAC740 4x4 wave to AP in a very redundant configuration and line rate manner, because we have 2.5 gig multi-gig NBASE-T PoE plus capability over here. So that was a good webinar. I hope we had some demo effects, but thank you very much for your attention today. Both M42 multi-gig solution and the WAC740 Wave 2 4x4 solutions are shipping with the gorgeous 4300 stackable series at the core. It's probably time for Q&A right now. Let's go over the questions. So yes, the webinar is recorded. So the marketing team will send you the link for the record. So no problem. We usually record all the webinars, and webinars are then live on the partner portal for you guys. So that's the pretty unique question I have on the chat box. Go ahead. We have 3 minutes left. I was longer than expected, but that's called demo effect. Everything was clear. Let me know. If yes, I really want to thank you all for your attention today, and I think I can hand it over back to Sarah. Thank you.
So thanks for joining us, and we'll see you next time. Have a great day.